Hello everyone, welcome to this tutorial. In this tutorial, I'm going to show how to use CSMHyk in Olga. CSMHyk in Olga is part of Olga. It's basically a plugin which simulates the growth rate. Hydrate equilibrium in Olga is determined by our fluid definition. So the first thing we will do in this tutorial is go and define a new fluid file. So for that we've got to go to multi-flash 4.4, and we all know when hydrates form at high pressure and at low temperature. So let's start creating our fluid file first. So let's load the problem setup. Users PCM multi-flash fluid file blackoil.mfl. So I've loaded the MFL file. So you first define your model setup. Because this is hydrates, we would want to use the hydrates model setup. We want to use CPA infochem. We want to uncheck liquid 2. We will only form hydrate 2. So we are interested in hydrate 2. We change the viscosity to mixing rules, thermal conductivity to mixing rules, and surface tension to mixing rules. So that's all done. So we define the model, so and say OK on it. Close that window. Now go to table to create the Olga file. So create a new tab file. So let's say CPA hide. So let's say CPA black oil. Say open on it. You can also give a hydrate formation file name. We want the hydrate formation in terms of pressure and temperature. uh, Multi-flash can generate that for us. So we just say browse. We can say CPA hide on it. Say open. The pressure and temperature starting and the ending bounds are pretty much the same, so we don't have to play with it. So let's calculate, say calculate table, and you can say here it clearly says that Olga has created the new tab file, and it has also created the hydrate table for us to be used. So we can close that, we can minimize that. So the next step is to open Olga 7.2.3 and create the actual model which is going to use the CSMHyk. So open case, we've got base case suite.opi. Let's open that. We'll say save as base case suite CSM hike and say save on it. So we could see here the base case suite case is actually loaded up, taking a bit more amount of time. So let's first, as we do always, duplicate the case and say base case suite CSM icon to it as well, and say save. So the next step is to go to library and right click on it and then add hydrate curve to it. So we know it's from the file and say S. So select the hydrate file which we created. So go on to ECM and we know go on to the multi-flash fluid file where we created the file as well. So we created the CPA black oil height. So we open that. We go on to the column header and say temperature is in Celsius, pressure is in bar, and say OK on it. So that's done. And the case definition, go on to the case, go on to the files actually, select the fluid file which we've already generated, remove this fluid file which is already there. So remove, go on browse, go back to ECM, go on to multi-flash fluid file and select CPA black oil, say open and say OK on it, and that just converts that back up. So we've added the hydrate file to it, we've added the fluid tap file to it. The next step is to add the hydrate check components to the flow path. Normally hydrates form on the flow line, they tend to even exist in the riser. Predominantly hydrates form on the bends in the pipeline. So let's go and add that functionality to our flow path. So let's go to flow line and say FA models to it and then add hydrate check and let's load the hydrate curve which you already incorporated in our file and say select and say OK on it. That's good, that's done. So go back onto the flow path, double click on it and add your go to FA models, add your hydrate kinetics option and go again to the flow path, right click on that, say add FA models and do hydrate options again as well. So for these hydrate kinetics we've got to enter some values which has been given in the detailed description uh, located in the tutorial section in the LSM website, so you can have a look at that. So we are saying model as kinetic, full dispersion as yes, uh, sea water as one. uh, yep, that's about it. And then go on to hydrate options and we don't have to change anything on that. That CSM fraction, that's an advanced hydrate model option, that stays the same. So that's about it, that's done. So what we can do now is to say copy on the FA models and go on to the flow path riser, right click on it and say paste instead. That should have got all your FA models there, the hydrate check, the hydrate kinetics and the hydrate options to it. So it's just an easier way so that we don't have to create it again. So we've added all these hydrate kinetics and hydrate check and hydrate options to both the riser and the flow line. The next step is to um, increase the number of segments we've got in the system. So here for example in the wellbore, go on to that, go on to the geometry editor. You can do it the other way as well. You can just go on to the properties You can do it the other way as well. This is, so if you go on to piping, pipe one, you said, okay, so this is pipe of the flow lines. So if, so it says, already says 100, so I'll make that as 130. Increasing the number of segments will increase your simulation time, but these are complex simulations and they use the higher order equations in Olga to solve and come up with an answer. So to get a proper converged solution, it's important you've got a finer discretization in your model. So go on to piping, go to pipe one. In the riser, you've just got 10 segments, make that to 50. Uh, on the flow path of the wellbore, onto piping again, and you've got 50 there. It should be good, but if you want to increase it, go up to 70 on that. That's done. So after that, the next important bit is to add the variables which we would use to analyze the results. So in terms of CSMHyk, it's very important to add two important variables. So let's go to the output and then go to profile data one. You're going to add two key variables. One is hydrate temperature. It shows the formation temperature of hydrates. Another one is called B hydrate. That's basically the amount of hydrates that are formed in the pipeline or in the system, or in that particular flow path which we define for. That's the volume fraction. So we go on to the variables, we go on to search, and we just type in high TM. We have it, click on that. We go on to that same window again and get B height for us. Click on that and say OK on it. So now we've added those two important variables which we wanted. The easiest bit now is to just duplicate it. So we've added it in the riser. We could easily get that onto the flow line. Before doing that, make sure you delete the existing profile data one, otherwise it just duplicates. So what we can do now, we can go on to profile data one. As shown in the previous tutorial, you could copy and paste onto the flow path. Paste. So if you go on to the flow path, flow line, and look at output, that should basically have your B height and hold up. So that's about it. You've defined what you could. As always, check whether you missed something. The verification is succeeded, and you can just double click on the run batch button and that will run your simulations. It should be noted that your simulations is going to be very slow because you're using a plugin, and this plugin is a very advanced module and it uses higher order simulations to converge, and you also increase the number of segments of the pipe in different flow paths in the system. So that's going to add to the simulation time as well. So when you've done with those, when your simulation finally finishes off, plot your hydrate temperature and your B height, and you could see at what temperature hydrates form and what is the amount of hydrates that are actually formed in the pipeline or in the system actually. uh, that's the end of this tutorial. Hope you enjoyed. Thanks.